So here's what we're going to do. We're going to trade out our boundary conditions. We're going to do the following. Instead of solving this equation, how about we do the following? We will specify that at A, it's alpha. But this is a problematic one. This is like knowing what the future is already. So what we'll do instead is say, how about we do this? Let's specify what the derivative is. Capital A. I don't know what capital A is. But if I prescribe this, I have enough information now to put into OD45 and march forward into the future. And how do I want to do this? Well, what I do want to do now is march forward into the future. And what am I trying to do? I'm trying to pick this A so that when I get into the future, I hit that beta. Okay? So I'm substituting. I'm saying I'm going to use all the techniques we have before, but I'm going to try to figure out how to pick an A so that when I start with this, that picking that A, when I look at time B, I hit the target. Okay. So how is this something that you already know? All right. You already know this for many reasons. It's an intuitive concept. It's called the shooting method. All right. So I don't know. Let's make something up. You are trying to throw a rock and hit a stick on a lake. You've done this, right? Right? Everybody's done this? So this is you winding up, because everybody just does this. Starts early. My girls, they're 6 and 9, and every time you go down to the lake shore, there's a rock thrown. Okay, then it goes, and then maybe like it's really cool if you have a little stick out here and you try to hit that thing, right? It's totally irrational, but we do it anyway, right? So what do? Well, okay, first maybe you throw it and you splash there. So what do you got to do? Well, then you maybe throw it a little higher, you splash there. And you know what you're doing here, and then maybe you start figuring out, okay, I got a little closer, and then you boop, hit the thing. Okay, and you get a point. And then you have your brothers there, and you try to figure out how many points you can get more than them. Right? Something like that. All right, so that's the game you might play. And then let's talk about what you actually did here. You are the boundary on the left. And when you're in here, FA equals MA takes over. And this is equivalent to your target. So what you keep doing is you keep adjusting your initial condition to try to hit this target. Normally, you might release here, let's say you throw it at the same speed, about the same height every time. Like if you're a big strapping dude like me, 6'1", tall, huge muscles, you can tell, right? Well, I try to cover it up with the suit a little bit. But you throw that thing about the same speed every time maybe, and about the same release, and then you might just change the angle a little bit. Okay? So it's probably what you're mostly doing. So what you're really doing here is you're changing the launch angle. Hey, wait a minute, isn't that kind of, when we start thinking about this here, what is dy dt? It's a slope, it's an angle. This is your launch angle. So you're going to change your launch angle, and this is kind of fixed, releasing from here. And you keep changing this, and you keep doing different one of these until what? Until you iterate, until you hit the thing right there. Okay? Same process happens if you're shooting free throws. If you're trying to shoot free throws, if you overshoot, you hit the backboard and bounces off. If you undershoot, you get an air ball. That's more embarrassing than coming off the backboard. And then you try to get yourself a nice little clean Michael Jordan type shot. Okay? All right, so this has the method of shooting. That's it. What your job is to do is tell your computer how to guess and how to keep changing your angle here so that you hit the target. Okay? It's a very constructive way to do this. So you're going to write a routine to do this. So how would you do something like this? Well, let's come back over here, and let's think about how the process might work. Let's say you take off here at time A and you're trying to hit a target here, time B, this is your beta value here, this is alpha. Now the nice thing about the computer is that it's pretty, takes directions well, and it also can just keep cranking away on these things, and you can basically come up with an algorithm that will constructively go and get this thing, okay? So you say, if I took off and I found my solution, let's say this is A1. I started off with some A1 that I just picked, and I went across here and I found that, oh, look at that, I am below where I should be. All right, so let's try another one, A2. Suppose I do that one and I end up way up here. And that was my A2. These were just maybe guesses that I had. So I have A1, I have A2. And then you might say, oh, I'm trying to hit beta, and somewhere in between there is this perfect angle I'm looking for. So let's think about how to construct a routine to do this. If you're on, if you're going to train your computer to do this, what you might do is just something like, I'll bisect those angles. So for instance, I will say, well, what I'll do is, knowing that A1 I'm too low, A2 I'm too high, I will pick A3 to be halfway in between. Then I go across, maybe I run right there. Now what do I know? Now what I know is it's between A2 and A3. So you might say, okay, let's pick my next guess to be A4 is, and this is a very unsophisticated technique. You can do better, but this is just for illustrative purposes. So I cut it in half again, and maybe I take off on A4. I land here. Now I know it's between A3 and A4, right? So let's say A5 is, do you see the process? I keep going. It's another iteration routine. So what we've had before is we had an iteration routine we set up to go from time A to time B. And now what we do is going to just keep doing that over and over again. So I have an iteration routine. It takes me here to here. But now I just keep iterating and keep getting new angles, and trying to hit that target. Now a couple comments here. Can I ever hit that target? Yeah, you need a tolerance because at the end of the day, remember, most likely whenever you pick these numbers, you're going to land, you can land within 10 to the minus 16 of that thing. Is that hitting the target? Pretty much. Depends on what your tolerance is. If you need to be accurate within 10 to the minus 20, MATLAB's not going to get you there. But if you just say, you know what, if I just land within 10 to the minus 2 or 10 to the minus 4 or 10 to the minus 6 of that thing, that will be my solution. So you're going to keep iterating until you get to whatever your specified tolerance is, and then you stop that routine. Say, boom, got my answer out. Okay? So the method of shooting solves the differential equation with OD45 over and over and over and over again until it reaches the desired accuracy that you get to prescribe. Okay? That's the concept. That's about it. And it's basically making use of the tools we learned on Monday and Wednesday and Friday last week. Just, use OD45, but now with just one extra loop around it. Okay? So whenever we iterate, we have a loop that just walks through iterations to go across. And now you have to put a loop around the side of that saying, okay, now I have to iterate through A values. And I have an if statement in that loop saying, if I hit the tolerance I want, stop iterating. Okay? That's it.